Good afternoon to everybody. My name is Lorenzo Borselli, as I am the author of Slope Stability Analysis Program, SSAP, that you can find as a freeware tool and completely freeware, no commercial, in internet. In this video, I will show you a comparison between the results given by the well-known and excellent software Slide 2 produced by Rocscience with the results of this example as given in the verification manual of Rocscience. We show the example number 7 at page 44, slide verification problem 7. That is given from Giam and Donald in 1989. It is a well-known slope that is used as a verification test and benchmark test for many software. Is a slope that have inside small strata, horizontal strata, with very weak material, with only 10 degrees of internal friction. Instead, the other parts have higher cohesion and angular internal friction. This is given as a slope test for many software, and as well as being used also for SSAP. The reference value given in literature for these kinds of example is between 1.24 and 1.27, depending the method of calculation. For example, Spencer or GLI method as Morgenstern Price. Both these methods are as well present in SSAP. Well, now we will see the comparison in SSAP with this kind that we analyze with this kind of slope using two engine different. One Convex Random Search, that is Monte Carlo brute force methods, and other one named SNIFF Random Search, that is not a brute force method, as well is not an optimization method, a completely different method. The SNIFF search that I will show in the second phase will be I will show this. In this case, we have the model, the same model that can you find in literature of many papers, and with the same parameters. For example, straight 2 with 10 degrees of angular internal friction. Well, we can run the model, global search. It's interesting to note that the methods generate a polygonal surface that is not vinculated to a specific shape. For example, is not vinculated or limited to circular one, but as well is produced free shape compatible with sliding, in this case with convex shape. But in this case, the results will not arrive at the indicated in the literature. For example, a brute force with this kind of limitation, even if the weak strata influence the results, as in this case, but is not generate, it not arrive to generate the reference value of 1.24 that we must arrive. This is just to change English, the language of QCAD that he used, this software used to show the results, temporary results during the calculation. Practically, he arrive at the end, we arrive at 1.38, no less than this value, because we have enough possibility with this shape to arrive, except in case of generating 1,000 more surfaces and more time. But what is the difference with others? Well, now I can show that the possibility in SAP to produce a special smoothing techniques the surface just before calculate the safety factor. This will produce more aesthetically better surfaces, but it's not necessarily surfaces that are exactly or arrive rapidly at the lowest safety factor, reference safety factor of 1.24. It's important that consider the situation of here we have the difference in between the last 10 surfaces with lowest safety factor. As well, in this case, is not enough to arrive at satisfactory results using these very rude and brute force methods. But when we pass at the next one, the things will change completely. So we have stopped the searching because we have seen that the results, of course, is not the best things here. And then now we pass at the SNIFF random search. A completely different engine. I remember that is not optimization engine, is not brute force engine, but it ran with completely different process and algorithms. SNIFF ran as it is developed in the 1997 and then developed continuously until now. We have a lot of options that we not commented and we not use here, but use in the simplest way. We have many options as the dynamic attractor, that is one other the issue important. Okay. And then we pass, just to see that it's the same, exactly the same model that before. We don't reload the model because it's present, and we can see that the layer is, the weak layer is only alpha meter depth and or completely horizontal. Okay. This is the same parameters. Angular internal friction cohesion. the weak layer 2 have cohesion 0. Okay. We remove the smoothing of the surface because the methods given in literature don't use any kind of smoothing. And of course, we don't activate any correction for limited state design that are equally present. We use directly the method as is given, or these parameters as given in the literature, geometry and geotechnical parameters. Run it. Okay. Remove the effect of tension crack. Look. Less than 1000 surfaces, and we arrive practically very close of the reference values given in literature. Yes, we have a 1.27 as minimum safety factor. We came at the beginning of the literature. The weak layer horizontal is traced by the method because it found, and we has 3000 surfaces, and we arrive at 1.24 of safety factor, minimum safety factor. We can improve a bit the processing. We leave a bit more, 1 minute more, the processing, but we can see the difference with the other one. We have the possibility to trace better automatically the weak layer and surfaces. In the meantime, we can see the graph. You can see the graph. The processes continue. Of course, SNIFF Random Search a bit less less speed that the other one, but much more effective when you have complex strata and complex geometry and distribution of shear strength inside the slope. Practically, we arrive at the same values considered valid in literature. This is the last safety factor, the safety factor with minimum safety factor, the surfaces, and then we arrive a much more restricted critical zone inside. The block search method used by Slide or other program with Stable is not used here. We don't need it. Is enough look, run we have practically about 2% of difference between the last safety factor surfaces and the last one, 10th of the last 10 surfaces with lower safety factor. And we have completely inside the reference interval considered valid in the literature for this kind of the slope. You can see the critical and the surface with lower safety factor with Spencer method. SSAP have also other tools more than SNIFF Random Search. Not only different method of calculation and some more methods to calculate and stabilize the numerical solution. This is another important things. but also have some color maps that I'll show you. Okay, this is the final results after 15,000 surface generated. This is the, well, what is the last one? Okay, this one is the lowest safety factor. Okay. Of course, we can also see the internal force associated with the minimum safety factor of surfaces. This is the distribution of tangential and interwedge force, tangential and horizontal interwedge forces, and as well we have the possibility to see other parameters like the safety factor along the sliding surfaces. We can show, because SSAP use also another methodology in parallel with the advanced limit equilibrium method that allow to obtain, for example, let me show here the green line, how change the safety factor local along the sliding surface that is indicated in red color. But this is as a hybrid method between limit equilibrium and finite elements. These are various kinds of map. I show you one of this one. Look the results. Few seconds, sorry, to generate this map. Look, the red one corresponds to the area where we have a local safety factor less than 1. And as well, we can show it is important, even if the global safety factor in limit equilibrium is 1.24, these areas corresponding at the weak layer have locally a local safety factor less than 1. And then what means that is an area where we can generate a progressive failure, a possibility of progressive failure. It's not the only kind of map. We have also the QFEM or quasi-FEM map, almost FEM map, because it's an hybrid method in parallel on this one, where using different criteria we see most interesting plots of where we can generate the possibility to generate residual progressive failure. This is most important to evaluate what is the most appropriate area where make an intervention, establish, for example, piles here or other kind of structure in order to stabilize or try to mitigate the instability. This is a safety map, classical safety map, given, for example, for Leszczynski method, given as Leszczynski con Ressa software, another excellent software, even is commercial. And we can see that from point of view of classical LEM, we haven't read points. Anyway, this only we conclude here. Many thanks for attention. This only for demonstrate that SSAP have many advantages with respect the other software, existing software. One of them is completely free and well documented with a manual 500-page manual available in the web page. Many thanks for your attention, and many thanks. Many thanks.